A car is at x1 15 meter. Remember, question 1, kinematics question. So x1 displacement 15 meter and is at t1 5 seconds and is later seen at x2 20 meter, t2 10 seconds. Remember, displacement is the same thing as saying x2 minus x1. So we say we should find the displacement. So the displacement is simply 20 minus 15, which is equals to 5 meter. That's the displacement. So displacement is equals to change in position. Now, let's say we should find the average velocity of the car. And we know that average velocity, V average, this is equals to change in displacement all over change in time. So this should be something as saying 5 all over t2 minus t1, which is the same as saying 5 over 10 minus 5. Shading. So this is the same thing as saying 5 over 5. So which is equals to 1. So t2 10 t1. So it's correct. So question 2. Let's move to question 2. Let's move to question 2. The particle has an average velocity of 108 km/h. How far? Whenever you hear how far, they are asking you for distance or displacement. Does it travel in time interval of 1 minute? It's equals to 1 minute. So first thing first, you need to remember what I taught you about kilometer, hectometer, decameter, meter, decimeter, centimeter, millimeter. When you are going this way, divide. When you are coming this way, multiply. If you still remember. So since this is in kilometer, 1000 meter. So when you are coming this way, you multiply. So that is the same thing as saying 108 times 1000. Then hour. Remember that this is per hour, and hour to seconds has 60 minutes, then 60 seconds, 60 times 60. So all over 3600. So that is how you do it. So to get V is the centimeter. So this is in the centimeters, meter per second. So then that the one in minutes, T, that is in 1 minute, is the same thing as saying minute to second divided by 60. 1 over 60 seconds. Okay. Remember, it's question 2 we are treating. So V, if you do the math, V is equals to 30 meter per second. Then are you kidding me? What are you saying? Why did I do this? How did I do 1/3? Are you okay? It should be. This one I was thinking of meter per second. This is setting as 60 seconds. May go no punish dog. 60 seconds. So 3,600 seconds make 1 hour. That is 60 times 60. So 60 seconds make 1 minute. 60 seconds. So that means that what I'm asked to find, they say how far S. So I've gotten V over T. So this is going to be S is equals to V over V is equals to S over T. So S is equals to VT. So which is equals to the displacement is equals to 30 times 60. So S is equals to 1,800 meters. Is your answer. So number 3, question 3. How long will it take a car? How long will it take a car with the average velocity 240 km per hour to cover a displacement of 20 km? How long? That is, they're asking for time. So question 3. How long T? You can hear how long is time they are talking about. Well, average velocity, the V there is 240 km times 1,000 all over. Hour to second is 2,000. That is Newton per second. To cover a displacement of displacement S of 20 km, 20 times 1,000 meter. So, but if I want, I can do this thing in hour. Since the 2 are in kilometer, but let's just do it. So this is going to give me 240. V will be equals to 66.67 meter per second. Then this S is equals to 20,000 meter. So they are asking for how long would it take a car to cover? They are asking for time. So remember that V is equals to S over T, displacement over time. So time will be equals to time should be equals to S over V. So this is equals to 20 in 1,000 all over 66.67. So 20,000 divided by 66.67. So we have T to be equals to 299.99 seconds. So 299.99 seconds. This is the time interval in 1 minute. So this is approximately T is approximately 299 points. Let's call it once. Okay, if I approximate this, T is approximately 300. Let's just call it 300 seconds. And we know that 300 seconds, if we do 300 divided by 60, so this is 300 seconds, which is the same thing as saying 5 minutes. So that's for that. That's question 3. Let's go to question 4. A car travels with a certain average velocity in half minutes. In half minutes, 30 seconds, and covers 900 meter. Find the average velocity. A car travels a certain average velocity in 30 seconds. That is half minute. 60 seconds make 1 minute. Half of 60 seconds is 30 seconds. Now, so this one is very simple, pretty simple. So, question 4. Solution. So, S is equals to 900. T is equals to half minute, which is equals to 60 seconds over 2 is equals to 30 seconds. So V, average velocity V is equals to S over T. So here is going to be 900 over 30. Very simple. So let's move to question 5. So question 5. Figure below shows the curve describing the motion of a particle. Find the instantaneous velocity at the time t equals to 2 seconds. So notice, this is the figure. So all you need to do is to come to the gradient, the slope. I told you this. That's what instantaneous velocity talks about. At the slope, you check the points you touched. So if this is our motion now, let's say this is velocity time graph. This is V. This is the area for T. So notice that at this point it touched here. It also touched here. So these are the 2 points that make this slope. So this is going to be the final velocity against the initial velocity. So 10 minus 5. So 10 minus 5. It said instantaneous velocity at the time. Find the instantaneous velocity at the time t equals to 2 seconds. So that means that this is actually displacement graph. So since d over t, displacement over time, gives you velocity. So that means we're going to have 10 minus 5 all over in a time of 2 seconds. So this is going to give me 5 over 2. That is my instantaneous velocity is equals to, remember, displacement over time. So this is going to give me, and displacement is changing position. So this is going to give me 5 over 2, which is equals to 2.5 meters per second. That's my instantaneous velocity. So this is my final answer. Number 5. Let's move to question 6. The equation of a displacement time curve of a particle is given by x equals to 10t squared. 10t squared. Find the instantaneous velocities at time t equals to 1 second and t equals to 2 seconds. That's question 6. So let's go. All I need to do is to remember that they gave me x, and x means position, and I can say, since there's an equation of a displacement, I can say that x here means displacement, 10t squared, and I'm to find instantaneous velocity. Remember that I said when you're moving from displacement to velocity, you differentiate. Assuming they said this is equation of velocity and they say find displacement, will integrate. So this time around, let's differentiate. X is equals to, differentiation is simply the power multiply the coefficients. It becomes 2 times 10, 20 t, then subtract 1 from the power, 2 minus 1. So x is equals to 20t. I've differentiated it. So what I have here, what I have at this point where I've differentiated, is now v, no longer x. This is x, but when I differentiate, it is now v and found. So this is my v. And they say find the instantaneous velocity when t equals to 1 second. So at t equals to 1 second, v will be equals to 20 times 1 equals to 20. Then at t equals to 2 seconds, v will be equals to 20 into 2. V will be equals to 40. So meter per second. Meter per second. Now, question 7. Find the average acceleration of a lorry which accelerates. Find the average acceleration of a lorry which accelerates from 0 km per hour. Wait. Question 7. Find the average acceleration of a lorry which accelerates from 0 km per hour. That is v from 0 km. So u, the initial velocity, is 0. Then the final velocity v is equals to 180 km per hour in 10 seconds. So t is in 10 seconds. So they're asking us to find acceleration. That's what it means. And remember that acceleration is equals to v minus u all over t. So let's check. This one, they gave it to us. This is the sentence saying 180,000 all over 3,600 meter per second. So let's do it. 180,000 divided by 3,600. So we get 50. We get 50 meter per second. So this is the sentence saying 50 minus 0 all over 10 seconds. So this is the sentence saying 50 over 10. So our acceleration is 5 meter per second square. Let's move to question 8.